Okay, types of equations that are useful at various times. Right, the usual type of equation you're used to seeing is referred to as a neutral species equation. Notice the states in. The states I got from your general knowledge about equations. So magnesium ribbon would come in as a solid, S for solid, hydrochloric acid, and the salt produced are floating around in water, so they have the AQ subscript, and hydrogen is a gas, G for gas. Now, we can acknowledge that the substances floating around in water are ionic, and hence in water they are not together as a whole unit, and that's where our ionic form of the equation comes from. So the substances that were aqueous are now written as individually separated ions. Notice that the balancing 2 in front of the HCl also carries forward for the ions produced when that ionic substance breaks down into ions. We can also notice that there are chloride ions on both sides of the equations, and hence they can be cancelled out. They are referred to as spectator ions. And if we do so, we get the net ionic equation in this form. Now, the concept of net wage is what's left after you take out all your deductions. And here the word net is used the same way. It's what's left after you take out the spectator ion of chloride, 2 of them both sides. Notice that I have the magnesium part of the story in one colour and the hydrogen part of the story in the other. And we can separate those stories out into individual equations, and they are called half reactions. So here's the magnesium story, here is the hydrogen story. Now those equations are not complete because yes, they are balanced for atoms, but we are also obliged to balance for charge. So 2 electrons needs to be added to the right-hand side of the magnesium equation, and 2 electrons need to be added to the left-hand side of the hydrogen ion equation. Because magnesium is being oxidized, it's losing electrons, and hydrogen, because the hydrogen story is having electrons added to the hydrogen ions, the electrons are on the left-hand side as reactants. They are referred to, this half reaction is referred to as reduction. Now we remember oil rig, because oxidation is loss of electrons, and the rig part reminds us that reduction, the R, is gain of electrons. Metals always have valency electrons they want to lose, so they will always undergo oxidation.